Seguimos en el tercer día del Mobile World Congress con más entrevistas de vídeo. Nos visita la empresa Qualcomm, que conocen de sobras, y nos visita Peter, con quien vamos a estar hablando no solo de lo que está presentando la empresa en el congreso, en su stand, sino que también nos va a hablar un poquito del concepto HetNet, que es uno de los temas que Qualcomm está cubriendo aquí en el evento. Peter, welcome to Television.com.
Thank you very much.
So I was thinking always that you will give us kind of an overview on what your company is presenting here. So if you can just give us a wrap-up of what Qualcomm is trying to communicate at the show.
Sure. We have three key themes at the show. Mobile computing, transforming computing with the latest generation of mobile processors that have grown up through the smartphone era, making computing more accessible, lightweight, longer battery life, better experience. We also have another theme called the Digital Sixth Sense that we're promoting through innovations like View4A, which will change the way we actually search for and acquire information off the internet, machine vision and device intelligence, network intelligence, bringing all that together. And the third theme, which we call the 1000X campaign, where the unprecedented growth of mobile data in the mobile industry has led us to the conclusion over the next 10 years we need to deliver an immense amount of capacity increase to the industry, working together with operators and network infrastructure vendors, and hence the 1000X really pertains to a view that the traffic growth will increase by about 1000X between now and 10 years from now. And that's really where HetNet falls into the three themes, is in the 1000X campaign. It's a very integral part of delivering this immense amount of capacity to the industry.
Now, does that mean that because of smaller base stations that the processors and the chips need to also be reshaped a little bit, or you can just reuse pretty much what, you know, the chips that were used on the classical macro cells, base stations?
That's a good question, and it's all an evolution, so it's an incremental step from where we are today. And the way standards have been designed in the 3GPP is with backwards compatibility in mind. So even as we move to these next generation of processors and modems, which will enable HetNet technologies to work very well, and as well on the network side, we have full backwards compatibility to all the earlier versions of LTE. And with multi-mode LTE chipsets, backwards compatibility to fall back onto 3G wherever there's no LTE coverage.
Okay. Now, in terms of HetNet, what are the main challenges that you see operators facing when trying to implement this kind of architecture? Because it sounds really promising, but obviously I'm assuming it has to have some difficulties as well.
Yeah, that's a good question. The real challenge in HetNet is the principle is you're basically shrinking the size of the base station, the node B, to basically deliver the same amount of capacity to a smaller area, which means each user on average gets a bigger share of the capacity. The problem with that is the way the networks are designed, and even in LTE today you have very large towers that have very high power. And so when you shrink the size of these smaller base stations that you're putting underneath this big coverage area served by a macro cell, is that the user's device can still only see the macro cell in many cases, even though the user may be right next to a small cell that has an enormous amount of capacity to offer. So the real innovation and the real challenge in HetNets is to enable the user device at some point in the transmission. In fact, in the HetNet standards, there's a point at which all the base stations stop transmitting except for just a tiny bit of information. And that's enough for the user to now see all the different sites, the big sites and the small sites, and transmit that information back to the macro network, which can now make the decision to hand that user over to the small cell, which has ample capacity.
But I thought the base stations, they use several links at the same time, like, you know, when you were changing from one to the other, and then the stronger signal would just gain, so to speak. So for a moment you would have, you know, connection to two base stations until one was stronger, and then that concept no longer applies for HetNet?
Well, there are actually different forms of HetNet as well, and one of the concepts is a multi-point communications link where the user's device can now actually receive simultaneously from two different base stations and combine those signals to add greater throughput. So that's one flavor.
That would be carrier aggregation, something?
No, actually a multi-point. So there's a multi-point type architecture, and there's also a HetNet. And actually in LTE Advanced, which is a broader umbrella term for a number of different innovations, such as HetNet. Also has a concept called carrier aggregation. That's about expanding the amount of spectrum that a user's device can receive on by taking two radio frequencies that maybe the device is capable of, and simultaneously receiving on those two instead of one, but thereby delivering a much higher data rate to each end user.
Okay. In terms of how to solve those issues, is Qualcomm involved in anything related to what you mentioned at the beginning in making sure the device knows when to connect to the small cell, when it's close to one instead of just being to the micro cell? What is your involvement with solving these?
Yes, we actually have started to solve those problems all the way back to 3G. Well, we have, like I said, it's an evolution. We have the first wave of features around HetNet called Ultrason, which we built Ultrason, self-organizing network. So one of the problems with small cells is the amount of cost and effort in engineering and deploying small cells. Being able to provision these small cells in a way where they know who their neighbors are and which frequencies are being occupied and how to hand over a user from one site to the next. Ultrason technologies actually allow that to be provisioned automatically. That's one aspect. There are many different aspects of Ultrason. But we've applied this to 3G and also plan to bring that forward into 4G LTE.
Okay. Anything else from your stand that you can comment to our audience in Latin America?
Yeah, in fact, one of the exciting things that we see in Latin America is the use of unpaired spectrum. So when we talk about delivering 1000x capacity, there are many different ways to do it. In fact, the three foundations of LTE Advanced, HetNet being one of them, is expanding the amount of spectrum you can deliver to one device. Carrier aggregations are very much a part of that, but also LTE TDD, which we see a lot of interest in Latin America for because of the amount of unpaired spectrum and the amount of refarming of WiMAX spectrum to LTE now. So everybody has moved away from WiMAX, and a lot of that radio spectrum is unpaired, which means TDD has an enormous opportunity in Latin America now.
Now that you brought WiMAX, WiMAX was supposed to work on 2.5 and 2.6 and 3.5?
Yes.
Do you expect seeing LTE in 3.5 at some point?
Oh yeah, absolutely. Down the road, I think it's one of the many bands that LTE will support. Certainly it's being discussed in 3GPP right now. 2.6 is obviously where the market is today. LTE has already 30 frequency bands assigned, roughly speaking, around the world. Almost 20 have been fully deployed. So one of the big problems in LTE is consolidating the amount of spectrum and having global roaming and devices that can truly be used anywhere to help scale mobile 4G opportunities.
So that means more work for you integrating all these bands into one single chip.
Yes, in fact, one of our announcements at the show was a solution called Qualcomm RF360, which actually allows an OEM now with a transceiver that can support any of the 40 bands that are specified in 3GPP and a radio front-end solution that can allow you in practice to get all of these frequencies, not all 40, but enough for global roaming into a single device.
Interesting. All right, well, Peter, thank you so much for visiting us, and good luck with,
Thank you very much.
with the show.
It's a pleasure. Thank you.
Thank you.